Now that you're feeling pretty good about elimination method and using it to solve a system, it's important to talk about other things that might pop up that you want to be aware of, problems that you want to be able to solve that don't work or don't look like the ones we've been doing. So on this problem here, you can see right away that the thing that's different about this problem is that it's not stacked up nicely like the ones we've seen before. It's not lined up so we have x's, then y's equals numbers. Really, the only thing you have to worry about on that sort of situation is actually rearranging it. So if you have a problem like this, rearrange it so you have x, y equals number. On the top line right here, that's a matter of adding 4x to both sides. And I'll just rewrite my problem over here. I'm going to end up with 4x plus 2y equals 12. And on this bottom guy, I need to move that 3x over, so I'll subtract that from both sides, and I need to subtract 85 from both sides. I'm kind of doing it all at once here. But you'll end up with negative 3x minus 11y equals negative 85. And once we get to this point, now it's like the problems we saw in our last video. Unfortunately, if we add right now, nothing's going to cancel. So we need to multiply by something clever, and you need to ask yourself if you'd rather cancel the x's or the y's. And since 11 is kind of a big number here, 2 and 11 would both go into 22, but you have to multiply the top equation by a big number. That's not all that appealing, so I'm going to try to make my x's cancel. I know that 4 and 3 both go into 12, so I'm going to set myself up so one of them is a 12, and one of them is a negative 12. So my top equation here, I'm going to have to multiply that by a 3. So when I do that, I'll write my new problem down here in green. I'll end up with 12x plus 6y equals 36. And my bottom equation needs to get multiplied by a positive 4. That way I'll have a positive 12x and a negative 12x. So I'm going to end up with negative 12x minus 44y equals negative 340. I'm pretty sure. I should get a calculator out for that one. Yeah, it's going to be a negative 340. So now I'm just going to add going straight down. And when I do that, I'm going to end up with negative 38y equals a negative 304. And when I solve for y right here, I'm going to end up with a positive 8. Just like we've been practicing in the past. Now that I have y by itself, I'm just going to plug it in and get x, and you guys have seen that enough times that I'm not going to bore you with that. You will end up getting an x equals negative 1 when you do that. So your answer to this problem is negative 1 comma 8. So that's just basically you reorganize the problem. You're dealing with something we've already practiced repeatedly. The two problems I have on this next slide are ones that would give you trouble if you saw them. If you came across this and was doing it on a test, you would pause after you got your answer and be kind of confused. At least I assume. I kind of set these up so they're really quick. Sometimes you might have to multiply an equation by something before you do it, but if you look at this problem right here, the x's are already going to cancel, so we don't have to bother. We're just going to add right away. So when we add, our x's cancel. Our y's actually cancel as well, though, because I have a 5y and negative 5y. So I have nothing left here. I just get 0 equals 14. Now 0 clearly doesn't equal 14. We've come across that before in a previous chapter when we got something like a variable's canceled. And if you recall, what we would say here is that there's no solution to this problem. It's the same deal here. There's no solution because in fact our lines are parallel. If you remember when we graphed these a few videos back, sometimes lines were parallel and they didn't cross, there was no answer. That's like if you were to get y by itself in each of these, graph them, that's what you would end up seeing. So if both variables cancel and you get 0 equals something that's not true, then you just say no solution. On this other problem right here, it's the same sort of idea where both of my variables cancel. I add, those both go away. I just get 0 equals, but on this one I get 0 equals 0. That's always true, so you have infinitely many solutions to this problem. That's the sort of situation when we were graphing, when it was the same line on top of itself. If you get y by itself in each of these, it's the same equation. So you would say, in this case, these are coinciding lines. So in elimination and in substitution, if you happen to be doing a problem and both variables cancel, you have to ask yourself if what you get is true or not, and that'll tell you what sort of situation you're dealing with.